Let's talk about finding equations of polynomials when you're given zeros and other information about the polynomial. Let's start with this one. We're going to write the equation of a polynomial with the following zeros. -1, 0, and 9. And it's going to be a third degree polynomial. And we're being told that the leading coefficient is equal to 1. Well, if we let f of x equal the polynomial, since -1 is a 0, we know that x plus 1 would be one of the factors of our polynomial, because it's always x minus that particular 0. If 0 is a 0, and remember, in place of the word 0, you can be thinking x-intercept. If 0 is an x-intercept, then x minus 0, or just x, needs to be a factor of our polynomial. And finally, if 9 is a 0, we know x minus 9 would be a factor. What we don't know until we read this is what the leading coefficient would be. If we only had this information that it was third degree and these were our zeros, there would be some unknown constant up front. I'm calling it a, and I just squeezed it in. But because we were told the leading coefficient is 1, then we know the polynomial is just 1 times x plus 1 times x minus 9. And sometimes we present the polynomial in this form. If you're asked to multiply it out, we could do that as well. I would probably multiply the binomials together first. So you would FOIL that out, and you'd have x squared minus 8x minus 9. And then I would distribute the x through. So we would have x cubed minus 8x squared minus 9x. So here is our third degree polynomial that has zeros, -1, 0, and 9, that has a leading coefficient of 1. Let's do another one. This time, we again have a third degree polynomial with leading coefficient 1, but this time we have zeros with 1 with multiplicity 1 and 1 0 with multiplicity 2. And when we get there, I'll remind you of what that means. So our function that we're talking about that represents our polynomial is some coefficient, some constant up front. We know that's going to be a 1 later, but I'm putting it there as a reminder for other problems. If 2 is a 0 with multiplicity 1, that means x minus 2 is a factor just one time. I'm putting the 1 there for emphasis, but that's because the multiplicity is 1. If 3 is a 0 with multiplicity 2, it means x minus 3 is a factor twice. So we would have x minus 3 squared. Since we know the leading coefficient is 1, that's telling us that a equals 1. And our polynomial then looks like this. We just said it. A is 1, so it is x minus 2 times x minus 3 squared. And we could multiply that out if we needed to, but let's not take the time to do that. Let's do one more that's a little bit different. This time we're going to find the equation of a polynomial function with zeros 5, -1, and -2 that is third degree. But now they don't tell us what the leading coefficient is. They just give us some information that the polynomial goes through the point to -108. So let's see what the equation looks like now. And I've used f of x. Sometimes when people are talking about polynomials, you'll see p of x instead. It doesn't matter, they're both functions. But now we definitely don't know the leading coefficient, so I'm going to put this a in, and often people forget that. Now the zeros are 5, so that means x minus 5 is a factor. -1 is a 0, so x plus 1 is a factor. And -2 is a 0, so x plus 2 is a factor. We can't have any more factors than this, because it says this is third degree. This x times that x would be x cubed, so there aren't any other unknown factors. But now here's what we're trying to find. This value a such that the polynomial will go through the point 2, negative 108. If we didn't have that information, suppose we only had this, here's what we could say about the graph. We know the graph would go through 5, negative 1, and negative 2. So the graph could look something like this. It's third degree, so maybe it looks like that. Or maybe it looks like this. We just don't know how steep it is or how flat it is, or even if it's going the other way, because we don't know what this a is. So here's our task. We're to find the coefficient a that would allow the graph to go through the point 2, negative 108. So if we're back over here, 2, negative 108, oh, it's way down here. I'll just put it right here. 2, negative 108 down here. We're trying to find the a that would allow this to happen. The graph to go up and down, go through that 208 and go back this way. Very roughly, that's what our graph would look like. What would the a need to be that would allow the graph to go through that point? So now let's come back to our equation. Our only clue is that the point 2, negative 108 works in the equation. So we're going to substitute x equals 2 and y equals negative 108 into the equation. So we put in negative 108 here. We have an a times 2 minus 5 times 2 plus 1 times 2 plus 2. And now we have an algebraic equation to solve with just one unknown. So we have negative 108 equals a times negative 3 times 3 times 4. Let's see the product of those. What is that? Negative 36. So we have negative 108 equals negative 36a. And when we divide both sides by negative 36, we get a equals 3. So we know that the polynomial that they're talking about right here, or was described right here, is f of x equals 3 times x minus 5 times x plus 1 times x plus 2.